Hi, I'm Laura McGrath, the Director of the Watershed Protection Program at Willistown Conservation Trust. Today we're going to be going over how to process a grab sample from a stream for conductivity and chlorides. So conductivity is a non-specific measure of contamination in a stream. And when I say non-specific, I mean conductivity levels can increase in the presence of a number of different pollutants. So we always like to pair conductivity measurements, which are used for an indicator of human activity and influence on our waterways, with chloride. And chloride is present in our waterways primarily through the introduction of road salt ahead of winter storms. So conductivity levels in the region of southeastern Pennsylvania tend to be very closely linked with salt levels. So today we're going to examine our samples from Okahocking Run at Rushton Woods Preserve for conductivity and chloride. Today I'm using the Hanna DIST 3 meter, which is a great low-cost conductivity and temperature meter. You can use whatever conductivity meter you would like. Just make sure before doing this testing that you've calibrated your meter to ensure that it's accurate. So if you were with us earlier for our grab sample collection, welcome back. We are going to be using the samples in a very similar way as we collected them. So we have a cup. It's not a special cup, it's just a plastic cup. But much like the process of collecting the sample, we want to be sure that we're analyzing stream water only. So we will be triple rinsing our cup with our stream water. So I pour maybe 1/3 to half of the cup full of water from our site, give it a swirl, and then dump it out. And if you're like me, I always like to keep a lot of paper towels handy because I tend to spill during this step. So once we've triple rinsed our cup, we'll fill it up with 1 to 2 inches of water. And the important thing is we want to make sure that the bottom of our sensor, where it's taking the reading, is fully submerged in the water. So I'll take my Hanna meter, press the power button, and then it turns on and tells me the air temperature. It's been sitting in the lab, and then we'll stick it into our water. So what is important is if you keep an eye in the upper corner, there is a small hourglass that's blinking. We want to make sure that that blinking hourglass disappears to get the reading. It can take a couple of seconds, so don't be anxious. All right, and it looks like our conductivity reading is 194 microsiemens per centimeter. So when you take your reading, you'll want to log it on a data sheet that has the site ID, the date, and the time of collection. So now that we have our conductivity reading, it's fast and painless. We can take our meter out of the sample, turn it off, and then we'll rinse it with clean tap water and pat it dry to store it for the next time we're using it. Next on the docket will be our chloride measurement. So we're using the Quantab low range chloride strips. And the low range is important because we're measuring salt levels in a freshwater system. The upper limit should not be exceeded, but we have definitely run into samples that were collected after winter storms that have salt levels higher than what our strips can measure. But if you're collecting at base flow, that shouldn't be an issue that you run into. And if it is, you should call your Penn State Extension office to let them know and find out what you can do to help your stream. So for our chloride measurement, we'll be pretty prudent and we'll give a nice triple rinse. Our sample's been sitting for a minute, so I like to give it a shake to make sure nothing's settled out. Give it another triple rinse, so anything that was on our conductivity meter is not transferred to our sample and giving us an abnormally high reading. And then we will fill our sample with about 1.5 inches of water. So when we are taking our chloride strips out, if your hands are a little wet from handling your sample collection, please do not reach in. These chloride strips are really sensitive to humidity and temperature. So they shouldn't be stored in your car in the summertime. They should stay in a temperature controlled space. And then we want to avoid introducing any humidity into the container. So I like to pour the the strips out just a little bit, so then you can pull the strip out without getting all of them wet. Now, there is a top and a bottom to these samples. The top says Quantab, and there's a T-bar that should be orange. We'll know when the sample is done processing because that orange crossbar will turn black. And a yellow peak will form, a little triangle will form on the strip. So when you're putting your strip into your sample, it's very important that the water does not rise above that orange crossbar, or else you'll accidentally trigger it to show that it's been completed before the test is actually finished processing. So we'll take our sample and stick it in, and you can keep an eye on it, but it can take a minute or two for this sample to fully process. So I'll see you in just a second when the sample's done running. Okay, our sample is done processing. This orange crossbar has now turned black. And you can see in a side-by-side, this is a fresh strip, and this one has finished running through our sample. So when we take a close look at our chloride strip, you'll see that there is a yellow triangle that's formed on the bottom of the strip. And we want to look at the number that the peak crosses in order to get an idea of how much chloride is in our stream sample. So the way these strips are laid out is there are thick bars that have a number on them, so 1, 2, 3, and 4, and so on. And then the small bars between those numbered bars are by 0.2. So it goes 1.0, 1.2, 1.4, and so on. So we'll take a good look at our strip, and it looks like the yellow peak crosses 2.6. On your Quantab chloride bottle, there's a conversion table. So this table gives you a number of Quantab units. That's the number that we're reading off of the strip. And you can look, if we're at 2.6, we'll follow our conversion table down, and 2.6 is 0.011% sodium chloride and 68 parts per million chloride. So that is the data that we put onto our data sheet. It's very important that we make sure two things. First is we want that black bar to be fully black all the way across to ensure that water has wicked all the way up the test strip. And second, when we're taking a peek at our peak, we want to make sure that we're counting the number that the actual point crosses. We don't round up or down or guess if it falls between two lines. We want to know the exact number that the strip is displaying. So once you record all of that on your data sheet, you're good to go. On your data sheet, you may be asked to record your latitude and longitude in addition to your site ID and potential address. The easiest way that I've found to do that is to open Google Maps, and you can see here we're located at Rushton Woods Preserve. However, I did not collect the sample at the Rushton Conservation Center. I traveled to the edge of the preserve where there is not an address. So what I do is click and hold to drop a pin on the site, and then there'll be an option that says near. When you click on that, it will give you your latitude and longitude for your location. So you can record those numbers in order to accurately capture where you collected your site, your data from. So. So one question you may have is, what do I do if the reading I'm getting from my test strip is less than or more than the conversion table numbers? So if you have a bottle in front of you, you can take a close look and you'll see that for this unit, or this lot number, the lowest quantab unit number starts at 1.4. However, on the strip itself, it begins at 0. So if you have a very healthy stream with low levels of salt, it's possible to get a reading that does not actually show up on your conversion table. On the other side of the coin, if you get a reading that is above the edge of the conversion table, this lot number ends at 8. However, my test strip goes all the way up to 10. You'll run into the similar problem. How do you report that? On your data sheet, you can note what your actual quantab unit number was, say 1.2, but my test strip doesn't start until 1.4 on the conversion table. You would note that it was 1.2 and you're unable to determine the percent sodium chloride or the chloride parts per million. You can write non-detect, or you can put in your notes section that it was less than the readable limit. Similarly, the same kind of reporting, it was over the readable limit for your chloride strip. Don't panic. If you're worried that you might have not done a proper testing, you can always run another strip on a fresh sample. So hopefully you're getting readings that are below the detectable limit, but especially if you're going out during winter storms, you can often find that we'll max out our test strips, and that's important data, even if we don't have the percentage or the parts per million. So good luck. A pro tip, if you find that the peak falls behind one of the numbers on the numbered strips, we like to turn the strip around and hold it up to the light, and you can get a really clear visual of actually what number you should be recording. So happy sampling, stay safe, and we hope to see you in the creek.